Today's topic is called Hess's Law. Okay, and this all is kind of based on this idea that enthalpy is a state function. If you remember, a state function does not depend on the path that it went to achieve its state. In other words, we don't care how the 50 milliliters came to be there. We just care that it's there. Okay, it could have been poured from 100 milliliters, or we could have added 225 milliliters. Doesn't matter. Okay, all we care about is the final result. So, what we can do is we can use this. If we want to find the enthalpy of a certain reaction, but all we have is a series of steps with delta H's, what we can do is we can assume that if a reaction is carried out in a series of steps, the delta H for the overall reaction is going to equal the sum of the enthalpy changes for the individual steps. Okay, you can pause this and you can rewind that and listen to it again if you need to. But we can add up the enthalpies of the sum of the reaction steps and then just take the sum of that, and that is our delta H of the reaction. And we can do this, once again, because enthalpy is a state function, and it doesn't matter how we got there. It doesn't matter how many steps it took. It just is the final result that matters. Okay? Now, this is definitely going to involve a lot of manipulation, and these are pretty complicated problems. So what I want to do is show you how to use Hess's law through examples. It's the best way to show you how. So let's do example 1. All right, we'll start out kind of simple and then we'll get a little bit harder. But assume that we're given the following reactions. Okay, we have solid carbon plus oxygen gas is going to go to carbon dioxide gas. Now, the delta H for that reaction is going to be negative 393.5 kilojoules. Now, this would be given to you in a Hess's law problem. So we have that reaction, and then we'll call that one reaction A. And then we're also given another reaction. We have carbon monoxide gas plus 1/2 of a mole of oxygen gas is going to go to carbon dioxide gas. Okay, and we're given that the delta H for this reaction is going to be negative 283.0 kilojoules. Now, our question is, let me move this guy up. Move up, move up, move up. Okay. Get back to my pen function. All right, our question is going to be, what is the enthalpy for the following reaction? Okay, so we're trying to find delta H for the overall reaction of solid carbon plus 1/2 oxygen gas going to carbon monoxide gas. Okay, so what is the delta H? It's a really ugly question mark, and I'm going to erase some of it. It's still ugly, but it's a little bit better. Okay, and I'm going to move you up just a little bit here. These are pretty long problems. Okay. So the first step is we have to look at the equations that we're given, okay? So we're given equations A and B up here, and we need to use those steps as a way to formulate the delta H of our final reaction here that we want. So what we want to do first is identify the different parts of this equation that show up in equations A and B. And we're going to have to pay attention to whether or not these things are present in A and B as products or reactants, because that's going to be very important. So, our solid carbon we find right here. Okay, and then we have O2 gas. Now, what I would recommend is, since these are both reactants, here and here, let's just use the O2 up here. Since it's in both places, we're just going to use the O2 up here because this carbon that's solid over here is also in the reactant side, and you'll see why this is important in just a little bit. Okay, and then finally, carbon monoxide. Okay, it's over here. All right, so now what we can do is we're going to basically write this like an equation. So we're going to use this first equation, A, as is, because we didn't have to change anything. So we're going to rewrite it. Okay, I'm going to draw a little line here. All right, we're going to rewrite it as solid carbon plus O2 gas goes to CO2 gas, and our delta H is going to be unchanged because we did not have to change this equation at all. However, equation B needs to be flipped around because right here our carbon monoxide is in the product side, and right here it's in the reactant side. So we're just going to flip the equation. So we're going to get CO2 gas is going to give us carbon monoxide gas plus 1/2 O2 gas. And then for this delta H, since we had to reverse the equation, you guys have probably already guessed this, but we are going to flip our sign. So we're going to have a positive 283. I'm going to leave out the units here for the sake of space. So we've done all we can do. I'm going to move this up. I need a bigger tablet. Okay. So now what we're going to do is we are going to cancel some stuff out. Okay, so anything that appears on each side of the equation is going to be canceled out. So the CO2 gas appears there and there, so we're going to cancel it. And for this oxygen, it's a little bit more complicated. We know that there's 1 mole of oxygen right there, and we know that there's 1/2 right there. Now, in order to make this easier, working with fractions, what I can do is I can erase that, and I can rewrite it as 2/2, because 2/2 is equal to 1, right? So I can actually subtract this. I have 2/2 up here, and then I have only 1/2 down here. So when I simplify this, I'm going to get rid of the 1/2, and when I do that, I no longer have 2/2 over here. I've simplified it, so I'm going to erase that. I end up with 1/2. So I can go through and I can cancel out. I have solid carbon plus 1/2 oxygen gas going to carbon monoxide gas. And all I can do here then is I can say negative 393 plus positive 283. So the final delta H is going to be a negative 110.5 kilojoules. Okay? Alright. So let's do another example. I'm going to move this up, and I'm going to go through this next one a little bit quicker. Again, if you need to, you can rewind this video or pause it. Move up a little. Get out of here. Get out. Good enough. Okay. Back to pink. Nope, back to white. There we go. Alright, here's example 2. I'm given the following equations. I have P4 solid plus 3O2 gas, P4 O6 solid. I'm given a delta H of negative 1640.1 kilojoules, of course, but for the sake of space. Okay, and then over here I have P4 solid 2. This is a 4. P4 solid plus 5 O2 gas goes to P4O10, which is a little bit different than the top one. And that's also a solid. Our delta H is going to be negative 2940.1 kilojoules. Okay, and we want to know, our question is, what is the delta H for, let me put this in a different color. What is the delta H for P4O6 solid plus 2O2 gas going to P4O10 solid? Okay, I want to know the delta H for that. Alright, so like I said, the first thing we want to do is go through our equation and find the individual parts. For our P4O6, we find it over here. Already we realize that it's on the wrong side of the equation. Okay, for our O2, let's see. For our O2, our best bet is going to be to use this one. And our P4O10 just shows up right here. Okay. And the reason I chose this one right here is, well, let me think here. Oh yeah, I gotcha. Because right here, I can already see, right up here, that I'm going to have to flip this one around. When I flip it, the O2 is no longer going to be on the right side of the equation. Okay. Alright. So we can rewrite it the way that it's supposed to be here. And when I do that, it's going to be flipped around. I'm going to have P4O6 going to P4 solid plus 3O2 gas. And of course I have to flip my delta H sign because I flipped the equation. So I have 1640.1. And for this one right here, our equation B, sorry I forgot to label these, our equation B, I don't have to flip anything. So I have P4 solid plus, let's see how many, 5 O2 gas is going to give us our P4O10. Okay, so I'm going to just draw a line here to separate what we're doing here because we got a lot of equations written. Since I didn't have to change anything, I just keep this the same. Negative 2940.1. And then I can go ahead and cancel anything out. Use a different color for that. I can cancel my P4s. And then I can simplify my O2s. So I've got 3 on this side and 5 on the other. So this gets canceled and we're left with 2 there, because 5 minus 3 is 2. I'm going to move you up just a little bit here. If you'll cooperate, there we go. Okay, and finally our equation is going to be P4O6 solid plus 2O2 gas going to P4O10. And then we're just going to simply add up our delta H's again, paying very close attention to our sign. And we're left with negative 1300 kilojoules per mole. Okay, and when we get to class tomorrow, I will go over another example. Otherwise, I do expect you to be able to do this, at least these simple problems, tomorrow when you get to class. Thank you very much.